All right, so 10 says solve the inequality and then answer, obviously using interval notation. So you've got 2x to the third minus 5x squared is less than 0. It's already got 0 isolated, so now I want to factor the left side. I can take out an x squared, and then I would get 2x minus 5 left over. When I split and solve this, and I go to square root both sides, the square root of 0 is technically plus and minus 0, which means that's a repeated answer, which is why it's important, because it messes up our pattern. Then the other side, I would get 2x equals 5 and x equals 5 halves. So when I go to set up my number line, I am just doing 0 and 5 halves, but I can't assume it's going to be every other one anymore because 0 is a repeated factor. So this is a situation in which you're going to plug in from more than one space. So if I plug in here, let's say I do -1, I would plug it back into the original. So 2 -1 to the third minus 5, -1 squared is less than 0. 2 times -1 plus, well, it should be minus 5 times 1 is less than 0. -2 minus 5 is less than 0, and -7 is less than 0. So this side works. If I plug in from in between here, let's say I plug in 1, I'd get 2 times 1 to the third minus 5 times 1 squared is less than 0. 2 minus 5 is less than 0, and -3 is also less than 0. So this section works. And then if I plug in something bigger, that would be 2.5. So let's say I plug in 3. 2 times 3 to the third minus 5 times 3 squared would be 2 times 27 minus 5 times 9, 54 minus 45, which is going to be a +9, and that's not less than 0. So I know that part of my number line doesn't work. So I'm shading from the 5 halves to the left, and it gets a parentheses because it's not an or equal to. And the interval notation on that is -infinity to, oh, I understand. This is, you can't include 0. So this 0 also can't be there. So it's like parentheses on the 0 to the left, which is why it's 0. And then 0 to 5 halves with a parentheses at the end. We're going to talk a little bit more today about like what that means, but basically you can't include the 0 because the 0, it's less than. If it was less than or equal to, I'd have a bracket on the 5 halves and I'd point my arrow all the way to the left. And today you're going to see it, so you won't really see it show up in this scenario on your test, but you are going to see it show up in the material for today, which is a fraction, and then you'll understand a little bit better. All right, 11, you're going to do the same thing. I can take out an x, and I'd get x squared minus 16, and then I have x, and I have x plus 4, and x minus 4, and then I get 0, -4, and +4. So this time it's 3, but none of them are repeated. I would plug in a point, so it should be every other. So let's say you just plug in number 1. I would get 1 to the third minus 16 times 1 is greater than or equal to 0. 1 minus 16 is greater than equal to 0, and -15 is not greater than or equal to 0. So the pattern goes every other one, which means I would shade in between the -4 and the 0 and the greater than 4. If you had the time to check, I would plug in maybe like a -1 and maybe a 5 to see what you get, but they would both work. And then the brackets go because it is or equal to this time. So it's bracket 4 to 0, union 4 to +infinity. So that you can see on your test. Like the other one you won't see where it's like that. You'll see, again, you're going to see why that's important when we get to the fractions today. But you wouldn't see a question like that with the quadratic or the cubic inequality. Yeah.
On our test, we're going to have to graph.
Yeah. Not all of them, but you will have to graph. Yeah. And you're going to have to give interval notation for all the inequalities. Yeah. So again, last section, that's going to get covered on your test. Last section we're covering from chapter 1, which is like been 3 months, I feel like, which is solving rational inequalities. So if you remember rational, this means fractions. So we're going to get something with variables in the bottom, and then you're going to get, instead of it being equals, greater than or equal to, less than or equal to here. So it kind of pairs a little bit of what we did yesterday with what we did with the rational inequalities, from the rational fractions from before. So your goal for these is to get the equation, again, isolated so that 0 is on the side by itself. Combine the terms so there's just one fraction. So if there's only one fraction, you move it to the other side, you're fine. But if there's more than one fraction, you have to combine them together. This could involve finding the least common denominator, changing them so they have them, and then combining them. One of the major differences between inequalities and rational equations is that you cannot cancel out variables. So I have to combine them into one fraction instead of multiplying by the denominator to get rid of it. If you multiply by the denominator to get rid of it, you just lost the test point. So you can't do that. Then you're going to split it up and you're going to set the numerator equal to 0 and you're going to set the denominator equal to 0. So where yesterday we took our two parentheses and split and solved it, now you're going to take whatever's in the top and whatever's in the bottom and set them each equal to 0. Then you're going to graph using the test points the same way we just did it yesterday. And then you'll determine your brackets and your parentheses based on your inequality sign with the exception of your denominator. The denominator can never equal 0. So whatever test point you use from the bottom is always going to get a parentheses. You can never put a bracket on it. So you'll see that when we do an example. But it's because it would be undefined, right? Like if we had a denominator that was 0, the whole thing is undefined. All right. So we start like this. I'm actually going to start with number 2, and then we'll go to number 1 because 2 is easier. 2 is already set equal to 0. So all I have to do, or greater than 0, all I have to do is split and solve these. So I'm going to split, and I get x equals -1, and I get x equals +4. And then those are what goes on my number line. And then I can easily grab 0 because it's in between those, and I plug it into the original statement. 0 plus 1 over 0 minus 4 is greater than 0. 1 over -4 is greater than 0. Is that a true statement? No. So we say the middle doesn't work. The outer two do. And because it's greater than and not a greater than or equal to, it gets parentheses. So I'd go -infinity to -1, union 4 to +infinity. Okay, so now go to 1. So what happens with 1 is there's no 0 on the other side, right? So I have to move the 1. So I get 5 over x plus 4 minus 1 is greater than or equal to 0. And then I can't have two separate terms. I got to combine that into one fraction. So I'm going to change 1 over 1 to be something over x plus 4, which would be x plus 4 over x plus 4. Now I combine my numerators, so it's going to be 5 minus x plus 4, which means that minus is going to both. Minus x plus 4 over x plus 4. That minus goes to both. 5 minus x minus 4 over x plus 4. And I'd get 5 minus 4, which is 1 minus x over x plus 4. Or -x plus 1, it's the same thing. Is greater than or equal to 0. With me so far? Good. Okay, now we split and solve. So in the top, I get x equals 1. And in the bottom, I get x equals -4. 0 falls in between them, so I'm going to plug that in. And you can plug this in here after you moved it, or you can plug this in here before you moved it. It doesn't matter. So if I plug it in before, I get 5 over 0 plus 4 is greater than or equal to 1, and 5/4 is greater than or equal to 1. Is that true? Yep, so I shade in between. If I plug it into the bottom, I get 1 minus 0 over 1 plus 4, and I get 1 over 5. This would have been greater than or equal to 0, which is still true. So either way, they'll give you the same ending result. Obviously, the equation will look different, or the inequality will look different, but the result would be the same. Now, here's the catch. Because it's or equal to, the numerator gets a bracket. Whatever the test point is that came from that numerator gets a bracket. So we solved the numerator and we got x equals 1. That one gets a bracket. But because my denominator cannot equal 0, this denominator cannot get a bracket. So it always gets a parentheses. So regardless of the inequality sign here, the denominator's point, like the one that comes from the denominator, will always get a parentheses. If I put a bracket on it, it means the whole thing's undefined if I use it. So then my interval notation is -4 to 1 with a bracket on the 1. So again, point from denominator always gets a parentheses. What are we going to do? Move the 4 to the other side. So 2x minus 1 over 3x plus 4. Minus 4 is less than 0. I have to make 4 over 1 become something over 3x plus 4. So I'm going to multiply by 3x plus 4. And I'm going to distribute. So I get 12x plus 16. And that takes over this. So this becomes 12x plus 16 over 3x plus 4. Yep.
Wouldn't it be -16?
So I can choose to either distribute it then, but then it would be -12 minus 16, or wait till after you find the least common denominator and then distribute it, as long as you do it one time or the other. So if I wait, I do 2x minus 1 minus, both of them are going to get the parentheses. Both of them are going to get the negative over 3x plus 4. And then distribute here. So I get 2x minus 1 minus 12x minus 16 over 3x plus 4. And then combine your like terms, and I get -10x minus 17 over 3x plus 4 is less than 0. Then I split and solve. So -10x minus 17 equals 0. -10x would equal 17. And x would equal 17 over -10. And then 3x plus 4 equals 0. 3x equals -4. And x equals -4/3. So I have this would be -1 and 7/10 and -1 and 1/3. Which one's smaller? Other way around. If it was positive, yes. If it's negative, the other way around, right? 7/10 would be less than -7/10 would be less than 1/3. So this -17/10 goes here. -4/3 goes here. Now if I want to use 0, where would it be on my range? On the right. So I can still use 0. I just know if it's right, I got to go point my arrows out. And I can go from here or I can go from here. It doesn't matter. If I go from the top, I would get 2 times 0 minus 1 over 3 times 0 plus 4 is less than 4. And I get -1 over 4 is less than 4. That's a true statement, so I'm shading like the oars on the outside. My inequality statement is less than, so what shape goes on those? Parentheses. And I get -infinity to -17/10 union -4/3 to positive infinity. Okay, so for number 4, we're going to start by moving 2 to the other side. So I'll get 6 over 5 minus 3x minus 2 is less than or equal to 0. I need to give 2 the denominator of 5 minus 3x. So 2 over 1 I'd have to multiply by 5 minus 3x. So this becomes 10 minus 6x. And I'd get 6 over 5 minus 3x minus 10 minus 6x over 5 minus 3x is less than or equal to 0. When I go to combine these into one fraction, this negative is going to go to both. So I get 6 minus 10 plus 6x over 5 minus 3x is less than or equal to 0. I want to combine my like terms on the top, so I get negative 4 plus 6x over 5 minus 3x is less than or equal to 0. Now I want to split and solve. So negative 4 plus 6x equals 0 and 5 minus 3x equals 0. I'd get 6x equals 4 and x equals 4 over 6 or 2/3. That's going to be one of my points on the line. And then if you want to add the 3x, so it's positive, I'd get 5 equals 3x divided by 3 and x equals 5/3 or 1 and 2/3. If that makes it easier to put on the line. Then I'm going to go to the line. 2/3 is less than 1 and 2/3 or 5/3. If I want to plug in the 0, it's going to be on the left here this time. So I'm going to come up to my original one. 6 over 5 minus 3 times 0 is less than or equal to 2. 6 over, this becomes 0. 5 is less than or equal to 2. And 1 and 1/5 is less than or equal to. So I know I'm going to shade in that direction and also the other way. Now the original is a inequality sign is an or equal to, which normally means it gets a bracket. But whatever came out of my denominator can't be a solution because it would make the whole thing undefined. So instead of the bracket, that 5/3 becomes a parentheses. The numerator, however, is fine. So that 2/3 gets a bracket. And my solution set would be negative infinity to 2/3 with a bracket on the 2/3 union 5/3 with a parentheses to positive infinity. All right, now we just get to the point in which on either side it's not just a whole number anymore, okay? So our least common denominator is going to be a little bit more complicated, that's all. So for 5, I'm going to move the 5 over x to the left-hand side, so negative, or you could have moved the one on the left to the right, doesn't matter. Negative 5 over 3x plus 2 minus 5x is greater than or equal to 0. Now, what's the least common denominator? X times 3x plus 2. So the one on the left, I would be multiplying. I'm not going to do the bottom, but I would be multiplying both the top and the bottom by x. And then on the right, I'd be multiplying by 3x plus 2, again, the top and the bottom. So my left numerator becomes negative 5x. The minus comes from the middle, 5 times 3x plus 2. And that's all going over x times 3x plus 2. Now you do not need to distribute the bottom. So I wouldn't waste my time because I would just have to factor it again to solve. So keep it separate like that. In the numerator, I'm going to distribute the negative 5. So negative 5x minus 15x minus 10 over x times 3x plus 2. Combine like terms in the numerator, negative 20x minus 10 over x times 3x plus 2. All of that is greater than or equal to 0. Good so far? All right, so now I split and solve. Negative 20x minus 10 equals 0. X times 3x plus 2 equals 0. The numerator, you can either add the 20x or add the 10. It doesn't matter. Negative 10 equals 20x. Divide both sides by 20. And x equals negative 1/2. The denominator has 2 factors, so I actually split it again. And I get x equals 0, and I get 3x equals negative 2, and x equals negative 2/3. So how many terms go on my number line? 3. negative 2/3, negative 1/2, and positive 1. None of them repeat though, so my pattern is still going to be every other one. I can still, why don't I put 1? That's a 0. Brain's working a step ahead because instead of having 0 this time as a plug-in value, the next easiest one is 1, which would be to the right of that. And again, you can plug it in at the beginning. You could plug it in after you simplified. It doesn't matter where. So from the beginning, I would have gotten negative 5 over 3 times 1 plus 2 is greater than or equal to 5 over 1. Negative 5 over 3 plus 2 is greater than or equal to 5. Negative 5 over 5, greater than or equal to 5. And negative 1 is greater than or equal to 5. Is that a true statement? No. So that section doesn't work. It's in every other scenario. So that means the section in between will work. The next section won't work. And then the last one to the left is going to work. Yeah.
How did you know it was going like from left? Because you said immediately that the 0.
You always have to do your number line from least to greatest. Is that what you mean?
I don't know.
Yeah. The negative 2/3 is the smallest. Then negative 1/2, then 0. And then I just looked for what was easy to plug in, which happened to be to the right of the one on the right. Like I picked 1 because I normally pick 0, but 0 is part of the answer, so I can't use it. So I could have picked anything. I could have picked like negative 1 and plugged in that. And then I would know that that section still works. So and then it's in every other.
No, I mean like we said that it didn't work because negative 1 was bigger than 5. So then how do you know?
So then that, wherever that came from, which was here, here, right, doesn't work. And then it's every other. As long as you don't have a repeated answer. If you have a repeated answer, that changes that pattern. Then you have to plug in from all those sections. But if it doesn't work there, it means it will work in the next section. It won't work in the next section. It will work in the next section. Now let's think about our parentheses and our brackets, right? The original one is an or equal to, which would normally mean they all get brackets. But whatever came from the bottom cannot get a bracket. 2 things came from the bottom, the 0 and the negative 2/3. So both of those get parentheses. 0 gets parentheses. 2/3 gets parentheses. But the negative 1/2 that came from the numerator gets a bracket. So it's negative infinity to negative 2/3, parentheses on the 2/3, union negative 1/2 with a bracket on the 1/2 to 0 with a parentheses on the 0. Yep.
So I don't really understand the part where you can tell if it's a bracket.
So normally we just go to our initial sign. And if it's or equal to, everything but an infinity would get a bracket, right? If it was just if there was no fractions, that's how it would be. Like yesterday's stuff, that's how it would be. But because there's a fraction now, think about anything that's in the denominator that would be 0 makes my entire thing undefined. So I can't use those even if it's an or equal to. Anything that came from the bottom. Yep. So the 2 that came from the bottom this time, this is x times 3x plus 2, right? Both of the ones that came from the bottom would always get a parentheses. And then if it was an or equal to, whatever comes to the top is going to get a bracket. Yep.
How can we distribute the x and then in parentheses 3x plus 2 doesn't cancel out in the bottom?
If I cancel, you mean here?
Yeah.
I can't cancel just part of a sum or difference.
Oh.
And even if they were in all 3 spots, you don't want to cancel. You just lost an answer. So you can't cancel any of the variables. If it's a number, if I can divide both sides by 2, sure, no problem. But if there's a variable there, like if there's an x in the top and the bottom, you cannot eliminate it because you just lost an answer or a test point. Yeah.
Why don't you distribute the bottom?
Because you're going to have to factor it back out to solve it anyways. Like if you do distribute it, right, I get 3x squared plus 2x. And then when I go set that equal to 0, I'm going to have to factor it back out anyways. So there's no sense in doing it. It's just extra work. It doesn't make it wrong. It's just extra work you don't need to do. Yep.
Can you show me that part? Because I'm kind of confused where you got negative 5 over 6.
-5/6. It's a 5.
Oh, okay.
Yeah, sorry, it looks like a 6, but it is a 5. Any other questions before we move to the next one? All right. Step 1 is what? Move it over. So I'm going to do 1 over x minus 3 over 2x plus 1 is less than or equal to 0. What's my least common denominator?
X minus 3 times 2x plus 1.
Good. So then I'm not going to rewrite the denominators each time, but this one would be multiplied by 2x plus 1, and this one would be multiplied by x minus 3. And I'd get 1 times 2x plus 1, which is 2x plus 1, minus 3, so this is going to get distributed to both, negative 3x plus 9 goes over your least common denominator, x minus 3, 2x plus 1 is less than or equal to 0. Then I combine my like terms. 2x minus 3x is negative x. Positive 1, positive 9 is positive 10. Denominator, I'm going to keep separate, God bless you, because I just have to factor it back out anyways. And again, I have 3 things to set equal to 0. My numerator, and then the denominator in both parts. So from my numerator, I get x equals 10. From my denominator, I get x equals 3. 2x equals negative 1. X equals negative 1/2. Order of least to greatest would be negative 1/2, 3, and 10. And we use the 0 again because it's not one of my answers. I'm going to plug it back in at the start. So 1 over 0 minus 3 is less than or equal to 3 over 2 times 0 plus 1. I get 1 over negative 3 is less than or equal to 3. This would be 0, so 3 over 1 is negative 1/3 less than or equal to 3. Yes. So that means that section works. And then there's no repeated factors, so it's an every other from there.
What do you mean by no repeated factors?
If I get 3 twice, then it messes up my pattern. Like that was the question that Jaylene had asked from homework yesterday. There was 2 zeros, and it messes up your pattern. Then you have to plug in from each section. Yeah. Okay, so then what am I doing? Parentheses and brackets. What gets a bracket? The 10, because it's from the top. And then the other 2 both came from the denominator, so they both get parentheses. So negative 1/2 to 3, union 10 to positive infinity. All right, so the first thing we're going to do is move that 3 over 2x minus 7 over x minus 5. Minus 3 is less than or equal to 0. The least common denominator would be x minus 5, so I'm going to multiply 3 by that. I'd get 2x minus 7. I can distribute the negative with the 3 or wait and distribute it later, but one way or the other, it's going to get it. Negative 3x plus 15 all over x minus 5 less than or equal to 0. I get negative x plus 8 over x minus 5. Split and solve them. I'd get x equals 8, and I'd get x equals 5. Go to my number line. 0, if you want to use it, would be to the left now. Plug it in at either place. So up here, I would get 2 times 0 minus 7 over 0 minus 5 is less than or equal to 3. Negative 7 over negative 5 less than or equal to 3. 7/5, which would be 1 2/5, is less than or equal to 3. So I'd shade the left side and shade the other outside. And then what came from my numerator was the 8. That gets the bracket. What came from the denominator is the 5. That gets the parentheses. I'd get negative infinity to 5 and 8 to positive infinity. Raise your hand if you got it right. Okay, good. Questions on anything that we covered today or yesterday? All right, so the web assign is open. It should be, yeah. You can get started on it. You've got 5 minutes.